Okay. Let's just think back here, and welcome to Calculus of the PM. 4.2 Implicit Differentiation. First thing I want you to understand is an operator. Because you really just do things. What are some operators from grade 5? Well, you might be like, what? You never call them operators. But if I tell you this is in between two numbers, you'd say, I hope you'd say, multiply. If I said this, something over something, divide. Okay, maybe not grade 5, but you've seen this operator. Take the square root of something.
When you said in between two numbers, like why would we multiply to find something between two numbers? But now I get
No,
it.
like
Between
4x,
two numbers.
2, 4 times 2. Yeah. Okay. So those are operators that you're familiar with. You don't question them. This is an operator as well. And it tells you to take the derivative with respect to x in that case. If I change it to d by d theta, do the derivative with respect to that letter. But only that letter. So, I'm going to just pause this. Okay, so what if, and we'll do the b one first, of course, and then c. This y could be an expression. This is kind of getting at what we were just doing in the previous question, 37. You notice that the variables don't match. So it isn't quite just do the derivative. If it was, I'd just say it's 6, right? But what if this y represents some expression here? What if this was d by dx of, and I said it was 6, and then, yeah, okay, x squared plus 2x. Okay. If I said this, right? Well, actually that's, yeah, I'll keep it as this. Okay. Now the 6 is sort of to resemble this. Yeah, that's why. You'd have to do the derivative, let's just see here, right? With the 6 times, what do you get as the derivative here? 2x plus 2. Okay. Does this make sense? Okay. Now, I don't know what that y is, but do you know that the answer will be, it could be x squared plus 2x, right? Well, what the derivative will be is 6, right, times the derivative of the y expression. Do you guys follow me on that? So, I'll call it dy by dx. We're using y notation. So that's, you know, that's an example there, right? Now, I don't know what the y expression is. I just made one up. So this is actually sort of like I said, what I was doing with the other expression there. It's 6 times whatever the derivative of that y expression could be. Because normally you just do it and you just write it down, just like I did above. Now this one, think about this. If I did the derivative, now the variables don't match. So this y to the 5 could be an expression with x's in it again.
Do the same thing.
But you kind of do the same thing. You do the derivative, minus 2, okay, it's going to be minus 2. Now the y to the 5, think about this. It'd be times 5. Now normally you'd say that y is something, right? What would you do if I actually had an expression in there, x squared plus 5x? You'd say
The derivative outside and
the derivative of the outside, leave the inside alone. Now he's doing all the talking, that doesn't mean everybody's following. In this particular case though, what are we calling the inside? Y. I don't need the blue brackets there, that's why I kind of shortened it up. Stuff that you don't actually need. Then you would do the derivative of the inside. I don't know what y is, but if you did, you just multiply it by the derivative. Now I'm going to put the brackets here just because I don't need them. The derivative of the inside. That's what I mean by apply the chain rule. Now if you had the actual expression, you would have just worked it out, right? Question.
Wouldn't you apply the 5 to the negative
Yeah, 5 times negative 2, yes. I just want to really break it down. So like negative 10 y to the 4. Yes. Yeah. Okay, so this is the chain rule without knowing what the inside is. And that's why I was thinking of the previous question this way. Now let's just see here. What if we apply the dy by dx operator to both sides of the equation and solve for the derivative? So what I'm saying is I'm going to take the derivative of y, and I'm going to take the derivative of x squared expression. I'm doing it, if I do something to one side, I do it to the other. If I took the square root of both sides, you know, or if I multiply by 2. Now this shouldn't be too surprising. This is sort of how this notation works. You might be like, huh? Oh. So what's the left side become? dy by dx, because they don't match, right? And then the right side is 2x, right? Better, because the variables match. Now, you might be saying, didn't you just make this more complicated? I always did this before, didn't you? If you take the derivative, and what I'm trying to show you is that initially we just said y equals x squared, the derivative is equal to 2x, right? But do you see how that notation actually works? You're saying, oh yeah. You're not actually explicitly writing this out and saying, well, the derivative of some expression called y is equal to 2x in this case.
We do the same thing in that side. So
Well-
dx squared over dx.
Well, this time, yeah, we're going to take a look at this. Now, do you notice, and I use this, do you notice this is a variation of the same equation here?
Yes.
Okay. So, let's think this through though. If I take the, oh, I don't have the magic there. I don't want magic pens. So the derivative of the y squared expression, the derivative of the x to the 4. Now, the left side, there will be something left over, right?
Yeah, d1.
Well, you've got to think of this as the chain rule. If y represents an expression, right? Y actually represents x squared, but we're not going to sub that in. So you'd say, well, 2 times the y expression, because they don't match, though, the derivative of y with respect to x. Huh? You follow that left side? Because I know you'll be able to do the right side. So when they don't match, 2y, okay. Now, question. Okay, stretch. Now I can solve for dy by dx just by dividing, right? dy by dx equals 4. I'm going to do it multi-step here. I think you can do it in one step. Which equals 2. Now, do you guys follow what we're doing there? Yeah, some do, some don't. Zach, ask him a question because you ask good questions.
Like, I understand, I don't understand why. Like, what is this finding?
Well, I'm starting with simple ones where you could actually solve for y, right?
So, yes.
But you find the slope of the derivative, yes, that's true. But
That's the slope, 2x.
you'd have to have an ordered pair to do this one, right? Now, this is a simple enough one that you could use other methods, but if you have an expression, which you'll see, that would be very hard to solve for y for, or can't at all, we'll work it through from left to right, both sides. And that's
So this is like solving derivative using algebra.
kind of. Yes. Well, let's just see. This is the, do you guys know, because you don't do this as much anymore. You know what formula, if you plotted this, it's not a function. And if you solve for this, you'd only solve for half of it because you'd take the square root of y squared and you'd get either the positive or negative side. You guys, what's that? Yeah, what's this? What kind of shape is this if you plotted all the x's and the y's that are ordered pairs that make this work? It's a circle. You used to, prior to 2012, you guys would have studied this, but they don't anymore. So this is the equation of a circle, and guess what? A circle is not a function, it's a relation. So this will come up with the equation for the tangent line here, here, oh, didn't mean to do that. Here, here, here. Will you get something there? It's undefined there, isn't it? Okay. So this is where this comes in handy. So I have to take the derivative of the left side, d by dx. I'm going to use brackets, x squared. Okay. Question, yes.
Anything y square equals to 25 minus x square. That's all of it.
Well, yeah, but you only get half the equation. You'll get the positive root or the negative root. You could do it as two. Talk to you about that after. Use this method right now, okay? But, so when we drag this operator through the left side, the derivative, and it's matching x. It's just 2x here. Plus the 2y, but it's a mismatch, so we say dy by dx. Because that y could represent something. It's, and then the right side is 0. Now, when we subtract, yes.
About the same thing.
Okay. I know. Well, I'll tell you about it. First of all, if you find any ordered pair on here and you put the x and the y in there, you'll get the slope of the tangent. Okay? Now, I think what your question was, what if you solve this right off the bat as y equals the root of 25 minus x squared, right?
Yeah.
Okay, you can do that.
No, I just get y square equal to 25.
Oh, you said y squared equals. Okay, that's easy. If you do this, though, do you notice that you're missing all of the... I thought you were talking about this. You're missing the bottom of this because it isn't the negative. This is plus or minus. If you tried it this way, that's why that...
But if you do square,
You'll get something that's very similar, but not the same. Oh, if you want to say y squared equals 25 minus x squared, absolutely, that works. And you do the subtraction first instead of after. That works too. Now I'm going to pause it here. And just wait, I'm going to just pause it here and then we'll get to your question.